part. How's the test?
Good. Bad. I don't know, every single problem one there was on the homework. Right, even like the ice on the ball. That was on the homework. Okay, now, calculus is divided into two disciplines. Differential calculus is the study of derivatives. So we have finished that. Now we are done studying derivatives. Now we're going to the second part of calculus. It's called integral calculus, the study of integrals. Right now you don't know what an integral is. Now, basically it's this. Let's do some physics review. If this is time and this is velocity, and you have a graph like this, here, let's see if we remember anything. Here's time. What does this area tell you? Displacement or the distance traveled, right? So for example, what if this is 5, the area of that is 5, and the area of that is 3? What is the total distance traveled by the particle from here to here? Let's say this is 0, 4, and 6 then. From 0 to 6, how far did the particle travel? What is the total distance traveled?
8.
The answer is 8, because it traveled 5 units to the right, then 3 units to the left, right? What was the displacement of the particle? 2, because since it's below the x-axis, it counts negative, right? So the answer would be 5 plus negative 3, which is 2. So this is the total distance traveled, this is the displacement. Now, when you took physics, probably the kinds of graphs that you were given were like this kind of graphs here. They're like rectangles, trapezoids, triangles, right? Things where you can actually compute the area. But in real life, it's not going to be like that. It's going to be like just general curves like this. So what we have to do in integral calculus is we have to figure out a way to compute these areas like that. So Sir Isaac Newton knew he had to somehow compute this area. And so what we're going to learn over the next several days is how to compute that area exactly. But tonight's homework, all we're going to do is we're just going to approximate this area by breaking it up into rectangles. So if you break it up into rectangles like this, if I add up these rectangles, is that going to give you the exact area? No, it's just going to give you an approximation. So, and there's several ways of adding up rectangles also. So whenever you add up a rectangle to approximate the area, we call that a Riemann sum. Named after the mathematician Georg Riemann. That's why tonight's worksheet, the extra problems on the worksheet is called Riemann sum extra problems. So let's look at an example. Tonight's homework is really easy. You don't need calculus for this. So suppose you have the graph of y equal x squared plus 1. So it's a parabola opening upward, shifted up 1. It looks something like this. I'm just going to go from 0 to 2 right there. So how can we estimate this area that's between the graph and the x-axis like this? So what you're going to do, these are the terms you're going to need for the book homework. You have LRAM, RRAM, and MRAM. That's what the book calls it. So this is called the left endpoint rectangle approximation method. What do you think the R stands for? Right endpoint rectangle approximation method. And what do you think M stands for? The midpoint rectangle approximation method. So that's what the book uses. When you take the AP exam though, they don't use this terminology here, but it really doesn't matter. So what if they tell you, okay, here is the area. Oh, by the way, I wonder if I should tell you this now. No, I'm not going to tell you yet. We'll wait till tomorrow. So LRAM 4, when you put a number over here, that means you're going to break it up into 4 rectangles of equal width. So here we go. How far is it from 0 to 2? 2. If I break that up into 4 equal parts, each part is going to be 2 divided by 4, which is a half. So this is a half, that's 1, that's 3 halves, and that's 2. Now, So we're breaking up into 4 regions. Now how can I make rectangles? Well, the first one is called LRAM. We're going to use the left endpoint to cap off the rectangle. So let's draw it a little bit more accurately here because it's increasing like that. So if I use the left endpoint like this, see, you cap off the rectangle using the left endpoint. If I add up the area of these 4 rectangles, that will give you an approximation. So let's do it. What is the base of the first rectangle? 1/2. What is the height? Right here. Well, the height is simply the y-coordinate of this point, right? Doesn't the y-coordinate tell you how much you go up? So when the x-coordinate is 0, how do you figure out what the y-coordinate is? You plug it into the equation. So 0 squared plus 1 is 1. There, that's the area of the first rectangle. See how there's no calculus? This is just geometry, adding up rectangles. Okay, second rectangle. What is the length of the base here? How far is it from 1/2 to 1? 1/2. They're all 1/2. Look, 1/2, 1/2, 1/2. That's what happens when you break it up into 4 equal parts. Okay, but the height of the rectangle is going to be the y-coordinate of this point, right? Because we're using the left endpoint. So if the x-coordinate is 1/2, how do you figure out the y-coordinate? You plug it into there. So 1/2 squared plus 1. 1/4 plus 1. 5/4. Okay, third rectangle. The base again is 1/2. The height is going to be the y-coordinate at that point because we're using the left endpoint. So if the x-coordinate is 1, you plug it in here to get the y-coordinate. 2. And then finally the last rectangle. The base is 1/2. The height is the y-coordinate of that point. Take 3/2, plug it in there. 9/4 plus 1. 13/4. Now on the AP exam, you write this on your paper, that's full credit. However, we're not there yet. I expect you to compute this number. So if I were me, this is what I would do. I would factor out a 1/2, that's what I would do. And then you would just get 1. But see how I wrote 4/4? Because I can see the least common denominator is going to be 4, right? Plus 5/4 plus, what is 2? 8/4 plus 13/4, and that's equal to 1/2 times. What is 4 plus 5 plus 8 plus 13? 9 plus 21 is 30. 30 over 4, but 2 goes into 30. 15 times 15 over 4. 3 3/4. So that would be an estimate of the area. Now let me ask you this, is this an underestimate or an overestimate?
Underestimate.
How do you know?
Because you're not counting as on parts.
Right, okay, because you can see that the area of these 4 rectangles is less than the actual area. But on the AP exam, when they ask you why, okay, that's not the, what is,
The second derivative.
no, it has nothing to do, it has nothing to do with the concavity.
Oh, the slope is increasing. Or
The slope is increasing.
So
No. Okay, I'll just tell you, because the function is increasing. The function. Because think about it, if the graph goes uphill, it doesn't matter even if it's like this way. When you make the rectangle and you use the left endpoint, see how it's less than the actual area? So what determines if it's an over or an underestimate depends on whether the function is increasing or decreasing. You get it? Because on the other worksheet, it's going to ask you, is it an over or an underestimate, and you got to give an answer. Okay, now let's do RRAM form. So this time, we're going to use the right endpoint to cap off the rectangle. So let's draw a new picture here. So instead of using the left endpoint, you use the right endpoint to cap off the rectangle like this. See? Doom, doom, and then doom, doom. And obviously, we can see it's going to be an overestimate, right? Why? Because the function is increasing, that's right. Okay, so would you agree that the base of each rectangle is 1/2? They're all 1/2? So instead of going 1/2 times this times 1/2 times that, why not just factor out the 1/2 from the very beginning? Yeah? Save time. Because that's what we did over here anyway, right, in that step. So factor it out from the beginning. So all we have to do is look at the heights of each rectangle, but isn't the height of each rectangle simply the y-coordinates of these 4 points right here? 1, 2, 3, 4? And we already did that, well, for 3 of them. What was the y coordinate for this point? Yeah, we did it already, 5 fourths. And then the next one? 8 fourths. Oh, we're thinking ahead. What about that one? 13 fourths. And then finally, what's the y coordinate of that one? Plug it in there, you get 2 squared. 4 plus 1? 5. What is 5? 20 fourths, right? See how we can save time by looking ahead? So that's 1/2 times something fourths. What's 5 plus 8 plus 13 plus 20? That's 13 plus 33, 46. But 2 goes into 46 23 times. 23 over 4 is 5 3/4. So you know what some people do to get a good approximation? They take the average of LRAM and RRAM. So what is the average of LRAM and RRAM? What's the average of 3 3/4 and 5 3/4? Come on. 4 3/4. In fact, 2 of your homework problems tonight is going to say, take the average of LRAM and RRAM. That's what you're going to do. So you got to do both and take the average. Now, MRAM 4. I don't know why, but even the BC students, some of them got confused with this. You're going to use the midpoint to cap off the rectangle. So, halfway between 0 and 1/2 is what? 1/4. 1/4. You're going to use the midpoint to cap off the rectangle. What's halfway between 1/2 and 1? 3/4. You use the midpoint to cap off the rectangle. What's halfway between 1 and 3/2? 5/4. Use the midpoint to cap off the rectangle. And finally, what's halfway between there? 7/4. We're going to use the midpoint to cap off the rectangle. And you can kind of see, this one's going to be a pretty good one because look, the overestimate right there is going to kind of a little bit maybe cancel out the underestimate there. So you might get a pretty good approximation. So let's do it. Would you agree the base of each rectangle is still 1/2? So let's factor it out. So what we need is we need the y coordinates of these 4 points right there. So let's do it. When the x coordinate is 1/4, how do you figure out the y coordinate? You plug it in. 1/4 squared plus 1. 1/16 plus 1. 17/16. Plus, okay, the next one. The next rectangle, the y coordinate of this point is going to be the height. 3/4 squared plus 1. 9/16 plus 1, 25. Hey, you guys are good. Okay, next. Plug that in to get the y coordinate. 5/4 squared plus 1. 25/16 plus 16/16. 41/16. And then finally, we need the y coordinate right there. So 7/4, plug it in. 49/16 plus 16/16. 65/16. This is probably the hardest part for you guys, is computing those things. Okay, let's add it up. 1/2 times something over 16. What is 17 plus 25 plus 41 plus 65? I would add these two first because 25 plus 65 is 90, right? And 41 plus 17 is 58. So 58 plus 90, 148. But 2 goes into 148. 74 times. We can reduce some more. 2 goes into that 8. 2 goes into that 37. So 37/8, which is 4.
Oh wait, no, 5.
No, 4. 4 and
5/8.
5/8. And isn't that pretty close to the average of LRAM and RRAM? The average of this one and this one was 4 3/4. That's kind of close to that. Now, is there a way we can get the actual area? Yeah, we can. Did your teacher in pre-cal regular, did your teacher teach you how to compute the area exactly on your calculator? Because we're going to do it without a calculator, but we're not going to learn that till 6.4 though. Yeah, we're going to learn the fundamental theorem of calculus, the most powerful theorem that you have yet to learn in your math career. Now, some of you are wondering, well, is there a way to figure out whether MRAM is an under or an overestimate? And the answer is no, cannot. You only can do it if it's LRAM or RRAM. It depends on whether the function is increasing or decreasing. But MRAM, no can. So take out your calculator and I'll show you how to do it. How can we compute the exact area? Yeah.
For this function, can't you tell that it's an underestimate? Because the slope is like getting steeper, and so the triangle on the right is going to be bigger than the triangle on the left.
Yeah. But it's not really a triangle though, right?
Right.
Too,
Yeah.
because there's a curve to it. I don't think so. Maybe you can, but you know the AP exam they're not gonna ask you because you really can't tell.
Okay.
Okay, take out your calculator. Who doesn't have a Casio? What do you have?
TI.
Okay, I'll tell you how to do both ways. So, this is what, so I guess I have to mention what an integral is, okay? So, this is what we want to compute. The integral, even though it's not going to be introduced till tomorrow, or the next time I see you, which is Monday. And then what you do is you put the function there, x squared plus 1, dx, you don't know what that is, you don't need to know that. And we want to compute the area between the graph and the x-axis from 0 to 2. So you put 0 on the bottom and 2 on the top. So that's what we want our calculator to compute. So if you have a Casio, this is what you do. You press, you got to be in the run matrix mode. Are you guys in that?
Yeah.
You press options, calculus, and then look for the symbol, the integral symbol. And then this thing pops up like this, and you just have to fill in the boxes. Like that, just fill in the boxes like you see right there. Now, if you have a TI, are you in the regular screen? You go Math 9. Oh, you knew already.
Oh, I don't know, I just guessed.
Okay, you have the older model. So you have this then. The newer model actually has the integral like you do. So you punch in the function. If you have, this is for TI, you have to put an X there, because that's just the syntax, and then 0 to 2. Press the enter button, and your calculator will compute the area of between the graph and the x-axis correct to within 5 decimal places. Basically what it does, see, can you see that if you add up the area of these 4 rectangles, you get an approximation. What if you want a better approximation? You make more rectangles, right? So if you want to be more accurate, just make 10 rectangles. Then what about 100? 1,000, a million, a billion? So what your calculator does, I'm pretty sure, is just adds up maybe thousands of rectangles, and so you will have 5 decimal place accuracy. So what is it? So if you have a Casio, it actually gives you the exact answer. I heard 4 2/3.
14
Oh, 14 thirds. That's the same thing, isn't it? Okay, 4 2/3. Now there's going to be a way we can actually compute that by hand, but like not until we get to 16.4. So 14 2/3. All of these are pretty darn close, yeah. Like if you average LRAM and RRAM, they're all pretty darn close. But that's how you compute the exact area of your calculator. Okay, let me give you one more. So to make sure you can use your calculator correctly. What if you have if you only had this last year in physics? No, but you guys only had baby pictures, right? Here is one hump of the sine curve, like this. Compute the exact area on your calculator. So, this area is represented by an integral. You put the function here, dx. Now, what do I fill in there and there? Where is here and where is there? 0 and pi. So that's why you gotta know something about trig functions. Punch that in on your calculator. Calculator spits it out. 2. That's kind of amazing, yeah? One hump of the sine curve. Area is exactly 2 square units. Actually, like I said, 6.4 will compute it. So tonight's homework in the book, all the problems are you're making rectangles of equal width. Okay? However, on the AP exam, they rarely do that. They rarely give you rectangles of equal width. So let me show you how it's going to be on the AP exam. That's why I had to make that other worksheet. There's only two problems, come on. So what they do is they give you a chart like this. They say something about like f prime of x. F is continuous first of all, otherwise no can do. And they'll say something like f prime of x is less than 0. And so they give you a chart like this. And then for some reason, they always put the x on the top, but that's the way it's done. Okay, is that enough? Let's do one more. So how about 1, and then 1, and who, and 3. Okay, good enough. Just make it like that. And then let's say the values, give me some values here. How about 8, 6, 3, 2. Okay. So using the values in the table, approximate the area between the graph and the x-axis using a left endpoint Riemann sum. That's how they're gonna state it on the AP exam. So what they want you to do is, using the subdivisions in the table, use a left endpoint rectangle to approximate the area. Now, if you need to draw the picture, you can draw the picture, but you really don't need to. Because look, it's easy. How far is it from 1 to 5? 4. So that's the base of the rectangle, right? On the x-axis. That's the base. And look at the two y coordinates. Which one do I use? The 8 or the 6?
8.
The one that's on the left. Because look, it says left endpoint. The one on the left, so it's 8. So that's the area of the first rectangle.
But how'd you get 4 again?
Because how far is it from 1 to 5? So that's why I said if you need to draw the picture, you can. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 to 5. So from 1 to 5 right here. And let's say you have a graph that looks like this. So 2, and then from 5 to 7, and then 7 to 10. You're going to make these rectangles like this using the left endpoint. But like I said, can you see the base of the first rectangle is going to be 4 then?
Yeah.
So you just ask yourself, how far is it from here to here? That's the base. Okay, next rectangle. How far is it from 5 to 7? 2, so that's the base. And what's the height? Do I use the 6 or the 3? The one on the left, the 6. And then finally, how far is it from 7 to 10? 3. And which height do I use? The one on the left, so 3. And then you can leave that, well, on the AP exam, that's full credit. On my test, I expect you to compute that, yeah.
What happens if it's negative?
Then you do just put negative in. Okay, and so you get 32 plus 12 plus 9. 32 plus 21. 53. Okay, now what if we do a right endpoint Riemann sum? This would be RS for Riemann sum. So same thing. How far is it from 1 to 5? 4, that's the base. What's the height? Do I use the 8 or the 6?
6.
Yeah, use the one on the right, which is the 6. Okay, next rectangle. How far is it from 5 to 7? 2. And which y coordinate do I use? The one on the right, 3. Finally, how far is it from 7 to 10? 3. And of course, I'm going to use the one on the right too. And then you add them up and you get 24 plus 6 plus 6, 36. You can see they're way off, yeah? That's because there's so much space in between. Look how much error there is right there. Okay, let me ask you this. For the left endpoint Riemann sum, the left endpoint, is it an under or an overestimate? Overestimate. So you would say, okay, overestimate. Why? Because f is decreasing. You have to tell the exact function. You cannot say it is decreasing or the graph is decreasing. That's not going to get you the point. You got to say f is decreasing. I'm trying to train you now. Now, what if you did a right endpoint Riemann sum? In other words, use the right endpoint to cap off the rectangle like this. Well, it's 2, so it's more like that. Is it an under or an overestimate? Under. Why? Because f is decreasing. That's right. Has nothing to do with concavity. It's whether the function is increasing or decreasing. Does everybody understand? You have to say f Because every year they go the graph. No, you gotta say f is decreasing. Now, can I do a midpoint Riemann sum? Yeah.
Can we say that the slope is negative?
No. No, I'm telling you exactly what you got to say. Don't worry, because I'm going to give you a cheat sheet in the first day of the fourth quarter. It tells you exactly what to say. I'm going to train you to do it correctly. Now, can I do a midpoint Riemann sum? Okay, this is what the mistake students make. If we do a midpoint Riemann sum, okay, first of all, how far is it from 1 to 5? 4. Okay, that's easy. Okay, what's halfway between 1 and 5? 3. What's the y coordinate for 3? It's not given, so you know what students do? Oh, just take the average of these two. 7. No, you cannot. Because how do you know the graph is like if it was a straight line, then it would be halfway in between, but most of the time it's not a straight line, right? So the answer is no, can do. You cannot do a midpoint Riemann sum if the midpoint values are not given. However, if they give you the midpoint values, then you can do it. But in this problem, see, there's no y coordinate for 3. You cannot assume what it is. Okay, so tonight's homework easy. No calculus involved. All you're doing is adding up rectangles. All right. Tomorrow, though, you're going to have to know how to draw graphs, which could be a problem. I mean, Monday. So if we cannot,
Hey, problem.